Navigate Science. I'm Mr. Moore.
And I'm Mr. Marmara.
How's it going?
All right, today we're going to talk to you guys about a few things. First, we're going to talk about chemical changes and physical changes. And we're also going to introduce to you how we describe these chemical and physical aspects with chemical properties and physical properties.
Excellent. What causes a chemical change? A chemical reaction. The definition of a chemical reaction is a process in which one or more substances change to make one or more new substances. A good example of this is something I enjoy very much, baking a blueberry muffin. Flour plus blueberries plus sugar and water, and add a little bit of heat, and you have a tasty, tasty blueberry muffin.
And you'll see this as we go into chemical reactions, but all the ingredients that you would have in a recipe would be similar to reactants in a chemical reaction. And what you create or produce at the end of your chemical reaction is called a product in chemistry. When we're undergoing a chemical reaction, you want to look for certain clues, things that will clue you in that tell you, I see, a chemical reaction is taking place. Those things could include the formation of a gas or odor.
Something I'm very familiar with, because Mr. Moore takes these a lot, Alka-Seltzer. When you have indigestion, you can take Alka-Seltzer. Alka-Seltzer are these tablets that will dissolve in a acid and will form bubbles. If you see the bubbles forming, you know a chemical reaction is taking place.
I'm glad you talked about Alka-Seltzer. I thought you were going to say that you were familiar with farting.
Oh, well, yeah, that too, but we won't go into that just now.
Formation of a precipitate is another really good example. This is one that a lot of students find challenging because they're not sure what the word precipitate means. But a good example would be soured milk. Basically, this is a solid that's produced in a chemical reaction where there was no solid before. We're going to show you an example of that a little later on.
Nothing frustrates Mr. Moore any more than when he's ready to have a big bowl of cereal and you pour the milk into your cereal and like big clumps of yogurt comes flying out and the smell, oh, it just turns your stomach. That is a precipitate. That is a solid forming in a liquid, and it tells you that a chemical change has taken place.
Absolutely. Another example would be heat energy being released or absorbed. So this next one, it's kind of the terminology that gets some people confused. Releasing and absorbing heat. Well, basically, when you do a chemical reaction, if heat energy is released, it will feel warm to the touch. And a word that we use to describe that is exothermic. Exo meaning exiting or leaving, and thermic meaning heat. Heat energy being absorbed will feel cool to the touch. Cool. So endo meaning in. So heat energy is transferring into the reaction, which would feel colder on the outside.
So good examples of this would be like a heat pack for anyone who likes to go hunting or camping. You get those little packs of hand warmers, and you break them and put them in your pockets, and then when it gets really cold out there and your fingers start feeling numb and you kind of lose feeling, you put them in your pockets where those heat packs are, and it warms your hands up. So some of you may be familiar with that.
And we used to have ice packs, but I guess you all used them all up in the nurse's office, so now they give you bags of ice.
Exactly.
All right, and finally, change in color. So this one does get a little confusing here. When we say change in color and we're talking about a chemical reaction, you're looking for a change in color that isn't there before. Okay, so the example here is spilling bleach on clothes. Your clothes that you put into your washing machine, maybe like your favorite pair of jeans, if you accidentally put bleach in there, they're going to turn white, and that's not a color that was originally there. So an unexpected color change would be an example of a change in color for our chemical reaction. We were talking about the precipitate before, so we want to show you a visual example of a precipitate. Alright, so again, a precipitate's a solid that forms during a chemical reaction that wasn't there before. So if you do leave milk out on the counter, don't try this at home unless you want your parents to get angry at you. But here's what you will end up with. Okay, so chunks of this kind of milky curd here inside this clear liquid. So this is a new product that's being formed. This was hopefully not in your milk carton when you started.
He had to say chunks, didn't he?
Alright, what could cause a physical change? Now remember, we had chemical changes before. Okay, physical changes are different. So we're not actually experiencing a change in the materials, but you're going to see a change in appearance somehow. So a physical change is a process in which the physical appearance of an object is altered or changed with no modifications to its chemical structure.
So it's made of the same stuff, it just looks different. And this is one that really trips up 8th graders a lot. Melting an ice cube, okay? That's called a phase change, changes of phase. However, solid ice or solid water, liquid water, and steam, it's all water. It's just in different phases. Water can be a solid, a liquid, or a gas, but however, no matter what form it takes, it is still H2O. It does not change chemically. The molecule does not change. It basically just changes phase from ice to liquid to steam. No matter what form it's in, it is still water. That is a physical change. How do I know if a physical change has happened? Well, you look for some signs. The first you're going to look for is a change in size. For example, cutting up a piece of paper. A piece of paper is a piece of paper, no matter if it's a whole sheet or if I sit here with a pair of scissors and cut it up into little bitty pieces. It is still paper. It does not change on the molecular level. It's still paper. Dicing an onion, cutting up a carrot. Again, it's still an onion. It's still a carrot. It does not change on the molecular level.
Absolutely. Change in state, like Mr. Moore was talking about before. Again, if you're changing an object from a solid to a liquid to a gas or any in between, that's only changing its physical appearance. Chemically, it's still the same. Another really good example would be dry ice. If you've ever seen dry ice before, it comes in a solid block, but as that dry ice is sublimating, what that means is it's going from a solid straight to a gas form. It does not melt. As it's sublimating, you see that kind of fog rolling off it. Okay, so that is a gas form of carbon dioxide. So you have solid carbon dioxide to gas carbon dioxide. It's still the same stuff, just a different phase. Finally, you got change in shape. Again, kind of similar in the change in size aspect. Right here we have an example bending a paperclip. When you change the shape of that metal that makes the paperclip, it's still the same metal. It would be pretty cool though if you could change the paperclip and like turn it into gold.
That would be pretty sweet.
But that would be a chemical change if you did that.
So what is the difference between a chemical and a physical change? We have two columns here. On the left we have chemical changes. With a chemical change, the reactants are different than the product. So the things that you start with before the chemical reaction are totally different from the product, which is what you end up with. So again, we'll talk more about that vocabulary when we start talking about chemical reactions. Again, what you start with, they're called the reactants, and they're going to be totally different than the actual products, which is what you end up after the chemical reaction. Also, there's a release of gas, or heat, or color, or perhaps a precipitate forms. And finally, with a chemical reaction must occur. So there actually must be a reaction between the two reactants, or the two things you start with, to form that new material, which is that product.
Absolutely. For physical changes, the product is still the same. So we have a difference here. Just because it's undergoing a physical change, it's still made of the same stuff. Okay? No release of gas, heat, or precipitate will be present, and no chemical reaction is going to occur. So you're only changing the physical aspects of the object.
Excuse me.
Please. Well,
excuse me. I think I need that Alka-Seltzer now.
I think you had school lunch.
That's probably what it is.
Okay, so a clever or corny, depending on how you look at it, way of trying to remember signs of a chemical change would be, please excuse coughs, sneezes, and burps. So for please, we have precipitate. Remember, that's the solids that are formed during a chemical reaction.
Excuse, we have an energy release. An energy release would be like a firework exploding, or something heating up, or something absorbing heat, something feeling warm to the touch, or something feeling cold to the touch.
We also have that unexpected color change, like the bleach dyeing those jeans of yours white.
Sneezes would be like a smell change, which would be like when Mr. Marmara passes gas and we basically have to get 50 or 60 feet away. We have to maintain safety.
It happens.
It happens.
And finally, bubbles or gas being released. All right. So the example that we had before was the Alka-Seltzer.
Yes.
When you pop that Alka-Seltzer in that glass of water, you're going to see bubbles being produced. Okay, so that would be an example of bubbling or gases released.
And that would be your burps. Please excuse coughs, sneezes, burps.
All right. So for physical properties and chemical properties, these are the tools that you're going to use in labs when we're asking you to describe physical aspects and your chemical reactions. So you need to be familiar with the differences here. Okay, so for physical properties, if we ask you to describe the physical properties of an object, we're asking you really to use your senses. So they can be observed or measured without changing the composition of the matter. So for example, if I ask you to describe the color of a marker, you're simply going to say the color of it. It could be red, it could be blue, but just because you're saying that doesn't mean, oh, now that marker's turned into a crayon, right? It's still the same stuff.
Physical properties are used to observe and describe matter. So when we're doing experiments and observing things, when we're using our senses, we are basically describing the physical properties of that matter.
And definitely get these down in your notebooks. All right. You want to include appearance of an object, its texture, so what it feels like, okay? The color, odor, melting point. So that is the point at which the object goes from a solid to a liquid. A boiling point, which is where it goes from a liquid to a gas form. Density, which of course we've talked about endlessly. Solubility. Now this word is when an object is dissolved in another object. So is it able to be dissolved or not?
Think of your powdered Gatorade or lemonade powder or Kool-Aid. We all love Kool-Aid! You take the powder, you pour it into the liquid and stir it up, and then you have a cool, refreshing drink. That's solubility. The powder is dissolving into the liquid.
And remember, just because it's dissolving into liquid doesn't mean you've made something new. You can still separate that powder out.
Exactly.
And many more, of course.
Chemical properties are characteristics that determine how a substance will react with other substances. So questions to ask: will it rust? Will it burn? Will it release a gas like Mr. Marmara? Or does it release bubbles? Will it explode? We love that. Can you cook it? Will it tarnish, decay, or mold? These are the types of questions we must ask when determining an element's chemical properties.
All right, so right here we have Caesium, all right, and this is an alkali earth metal. And this is found in the, I believe it's the first family.
Yes.
Okay? So it's the alkali metal. Some physical properties that you'll see. So these are pictures that you can see to describe it. It's obviously solid. It's very soft. Ductile and malleable. Now these are two words that we've talked about before. Right? Ductile, remember, means you can pull it into a wire shape, and malleable means you can change its shape or mallet it out.
Hammer it out. Yep.
Yeah. Okay. It's pale in color, as you can see. Has a low melting point, so you can turn it into a liquid very easily with very low amount of heat, and it has a specific density. These are all things you can measure and look at without actually changing it.
You can use your senses and you can determine these things. Chemical properties would be that it's highly reactive and unstable. It explodes in the air and it explodes in the water. Now we have a copy of this PowerPoint presentation that will be available to you on our Google Classrooms. On the next slide, I have actually included a video. We're not going to show it because I don't think it will appear very well with the distance of the camera and the amount of light in here. But if you do want to see something really cool and to watch Caesium explode in water, then you can just click on this YouTube link, and it is a video where you can actually see that occur. It's pretty neat stuff.
Yeah. All right, so I think next we're going to do for you a little demonstration to show you some signs of a chemical reaction, of course. All right, so I'm going to pull up some thermometers here.
Very important. What do we do when we do a experiment in the laboratory? We put on our goggles.
That's right, of course. All right, so the two chemicals that we're going to be using, four chemicals, that we're going to be using today. We have baking soda. Of course, we all know baking soda. And that's going to be right here. We have sugar, and we've diluted a little bit of water into the sugar to help speed the reaction for the video's purposes.
So we dissolved some sugar in the water.
There you
Sugar
go.
must be soluble.
All right. Now we also have two liquid chemicals here. We have vinegar and sulfuric acid. Okay?
Sounds scary.
So first we can start off by describing some of the physical properties of all these chemicals. Mr. Moore, you want to start with baking soda?
Yeah, baking soda, it's white. It's kind of grainy or granular. Doesn't really have much of a smell. Yeah, that's pretty much about it. It's density. It doesn't like it to be too dense, but yeah.
How does that compare with sugar?
Well, they have a lot of similarities. They're both white. The grains are a little bit larger. I would bet that the density of sugar is probably a little bit higher. So yeah, they're very similar, but there are definitely some differences.
Okay, so there's some physical properties for you. And for the liquids, we have two pretty different acids actually. Okay, so vinegar, as you can see, is a clear liquid, so there are two kind of descriptors there. It has a distinct odor, so the odor is pretty strong. Okay.
Mr. Moore loves Eastern style barbecue, which has a vinegar base, so just thought I would throw that in there.
Right, and we have our sulfuric acid here. It is a liquid. It's pink in color, as you can see, and this has an even stronger odor, kind of similar to rotten eggs in a way. Okay, yeah, kind of strong. Okay, so we're going to start off with the, I guess you could say, less interesting chemical reaction first, with our classic baking soda and vinegar.
Well, we want to end with a bang, right? Well, not really a bang.
Well, yeah.
That would be kind of scary.
I don't want to lose my classroom here, Mr.
Exactly,
Moore.
exactly. So we want to start out small, and then we'll amp it up a little bit.
Okay.
So, what's this that you have here? What do we have?
Wouldn't you like to know?
I would like to know.
Okay, well that's why you're asking, right? So right here we have a thermometer, also known as a temperature probe. Okay, yeah, and it is reading the temperature right now. So I'm assuming the people at home would like our temperature in Fahrenheit, probably.
Yes.
Although remember, we typically use Celsius in the science lab, but since y'all are at home without us, there you go. There's room temperature, 72 degrees, pretty close to it up here. So I'm going to wrap my hand around this temperature probe so we know which one we are using. As you can see, the bottom one is the one that is going up. Okay,
75, 76. So yes, so
All right.
you're using the bottom probe.
Okay. So I'm going to begin collecting data here. All right.
High tech.
Yeah. All right. So it's collecting the data, as you can see, and we're focusing on temperature 2. Okay. So I'm going to dip this into the baking soda. And remember, you're looking at the blue line, temperature 2. Okay. All right, so obviously remember, this is my hand, so it's settling nicely back to room temperature, which is about what the baking soda is going to be at. Right? Okay, look, it's starting to level off there. So the baking soda is just slightly warmer than room temperature, it seems, 75.5 or so. We're going to add the vinegar. Now, as we're doing that, keep in mind those signs of a chemical reaction that we talked about.
Yes.
And what are we excusing again?
We're excusing coughs, sneezes, and burps.
Right.
So the coughs, sneezes, and burps. What do we have here?
Take a look at what you might see in the chemical reaction.
Oh, okay. That wasn't so bad. I see. Oh, wow. I see bubbles. That would be burps. Please excuse coughs, sneezes, burps, bubbles. So do we have a chemical change going on here? Is this a chemical reaction? Absolutely.
Now, I'd like you guys to take a look at the screen behind me. Look at the blue line.
Wow.
Take a look at what's happening to the temperature. So it is feeling colder and colder to the touch. So that would be an example of an endothermic reaction. The heat is being transported into the product of the reaction, and it's being absorbed from the outside.
So endothermic reaction means it's getting colder, it's absorbing the heat from the environment, the heat is being absorbed into the reaction. Fascinating.
All right, next we're going to do the water and sulfuric acid reaction. Okay, so we're going to take our temperature probe again, dip it into the sugar. Now remember, we're switching over here to a new probe, a new thermometer, so we're using the red line now. Okay, so as you can see, the sugar is pretty close to room temperature there. All right, so we've already described the physical characteristics of both things, the physical properties. Now let's see if we see any signs of a chemical reaction here.
Ooh, it's turning orange. So it's gone from a pink and whitish fluid, and now it's brown. So we got a definite color change. And oh, it's starting to smoke. And the temperature, oh my goodness! 140, 150. Oh my gosh, we got a precipitate being formed. 200 degrees. 250 degrees. Where's it going to stop? 280. Oh my goodness. 290. 300 degrees. You can almost bake cookies.
You smell that odor.
Oh, it's nasty.
It smells like you're cooking, Mr.
Oh
Morphy.
God, like my wife's cooking. Don't tell us this. Woo! So, that is some nasty smelling stuff. So, definitely a chemical reaction here. It is exothermic. The amount of heat being released is tremendous, much more explosive, much more easy to see than we saw with the baking soda and the vinegar. Definitely a very powerful chemical reaction going on here.
All right, so to recap, you saw how we described the physical properties of each chemical. You saw the signs of a chemical reaction take place and the new products being formed. Okay, so please go back, make sure you recap all the new vocab, jot that down in your notebooks because you never know when you might need it.